everyone. In this video, we will discuss the memory-based question of CSIR-NET and question number 15. And this question is part B question. And let f power 2 plus f is equals to 0, where f is entire function and f power n implies nth derivative of f. Now in question, which of the following statement is true? Option 1, limit n tend to infinity, fn at 0 is equals to 1. Option B, limit n tend to infinity, fn at 0 is equals to minus 1. And sequence of fn at 0 where n belongs to set of natural number is convergent, and option D is this. Now come to explanation of this question. As we know that f power 2 plus f is equals to 0, where f is entire function, this can be written as d power 2 plus 1 into f is equals to 0, where d is a differential operator with respect to x. Now for solution, put d is equals to m. This implies that m square plus 1 is equals to 0. This implies that m is equals to plus minus iota. And now the solution of a differential equation, f belongs to ls, that is linear span, where s is equals to set of sin x comma cos x. Now according to given question, or for simplicity, case first fx is equals to sin x, and case 2 fx is equals to cos x. And case first, if fx is equals to sin x, this implies that fn x is equals to sin of x plus n pi upon 2. At x is equals to 0, fn 0 is equals to sin n pi upon 2. Now in sequence form, f1 0, f2 0, f3 0, and so on. Now as we know that the value of sin n pi upon 2 for n is equals to 1, 2, 3 and so on, this implies that sin n pi upon 2 in sequence form 1 0 minus 1 0 1 0 minus 1 0, and this implies that this sequence is a bounded sequence, and set of all limit point of this sequence is minus 1 0 1. This implies that the sequence fn at 0 not convergent, because it has no unique limit point. As we know that a bounded sequence is convergent if it has unique limit point, but this sequence has more than one limit point. This implies that this sequence is not convergent. So option A incorrect, option B incorrect, and option C incorrect. Now for option D, as we know that sequence or mode of fn at 0 is equals to sequence 1 0, this minus convert to 1 using this mode, and 1 0 1 0 1 0. Now take the odd subsequence of this sequence, and we get 1 comma 1 comma 1, that is constant sequence. This implies that convergent subsequence of this sequence. This implies that option D is correct. For verification, come to case 2, that is fx is equals to cos x. This implies that fn at x is equals to cos of x plus n pi upon 2, and this implies that fn 0 is equals to cos n pi upon 2. Now in sequence form, cos n pi upon 2 at n is equals to 1 2 3 and so on, this implies that 0 minus 1 0 1 0 minus 1 and so on. This implies that this is a bounded sequence, and but it's not convergent. Same logic, because it has a not unique limit point. This implies that sequence fn 0 is not convergent. This implies that option A, B, C are incorrect, and option D is correct. Now option A is incorrect, option B incorrect, option C incorrect, and option D is correct. Now come to next memory based question, and this question is also from part B. In question, let fn from closed interval 0 comma 1 2 are such that fnx is equals to n plus 2 into n plus 1 into x power n into 1 minus x for every x belongs to closed interval 0 comma 1. Now in question, which of the following statement is true? Option first is sequence fn is divergent on semi-closed interval 0, 1, and option B, Fn is a pointwise convergent sequence but not uniformly convergent sequence. Option C is Fn is uniformly convergent sequence. And in option D, limit n tend to infinity of integral 0 to 1 of fnx dx is equals to integral 0 to 1 of limit n tend to infinity fnx dx. Now come to explanation. As fnx is equals to n plus 2, n plus 1 and this, for x is equals to this, we can say that fx is equals to limit n tend to infinity of fnx is equals to 0 identically. That is fx is equals to 0, and we know that this fx is a pointwise limit. This implies that sequence fnx is a pointwise convergent sequence. This implies that option A is incorrect, because in option A we have given that sequence fnx is divergent. Now come to option D, that is limit n tend to infinity integral 0 to 1 of fnx dx is equals to integral 0 to 1 limit n tend to infinity fnx dx. As we know that from the previous explanation, limit n tend to infinity fnx dx is just fx. So this whole integral can be written as integral 0 to 1 fx dx. Say this side left hand side and this right hand side. Now come to firstly right hand side. As we know that fx is equals to identically 0, this implies that integral 0 to 1 fx dx is equals to integral 0 to 1 0 into dx. This implies that 0. Now come to left hand side. Limit n tend to infinity integral 0 to 1 n plus 2 into n plus 1 x power n into 1 minus x dx is equals to limit n tend to infinity n plus 2 into n plus 1, because these are constant for this integral, because integral with respect to x. So integral of x power n into 1 minus x is equals to x power n plus 1 upon n plus 1 minus x power n plus 2 upon n plus 2 0 to 1. This implies that left hand side is equals to limit n tend to infinity n plus 2 into n plus 1 bracket 1 upon n plus 1 minus 1 upon n plus 2. Further, after simplification, this implies that limit n tend to infinity n plus 2 into n plus 1 into 1 upon n plus 1 into n plus 2. This cancel with this. This implies that 1. This implies that left hand side is equals to 1 and right hand side is equals to 0. So this implies that option D is incorrect. Now for option C, we have to remember the result. That is, if fnx sequence is uniformly convergent to fx in closed interval 0, 1, this implies that limit n tend to infinity of integral 0 to 1 fnx dx is equals to integral 0 to 1 limit n tend to infinity fnx dx. This must be equal to this. If this sequence is uniformly convergent, this implies that this integral must be equal to this. But from previous explanation, this integral not equal to this. This implies that fnn sequence is not uniformly convergent. Now come to options. Option A is incorrect. Option C is incorrect. Option D incorrect. And this implies that option B is correct.